Hi, Jim here from Horizon Ag Tech. So today I wanted to talk about the concept of ground sampling distance, or GSD, and why it's important for agricultural mapping. Ground sampling distance is the amount of ground in each pixel of an image from a drone. You could also say it's the level of detail or the resolution of an image. So let's take a look at some imagery. So GSD is usually measured in centimeter per pixel. Here we have a 65 megapixel image from a Centera 65R sensor, meaning there are 65 million pixels in this image. A GSD of 1 centimeter per pixel means that each pixel captures 1 centimeter by 1 centimeter of ground. So that would be a fairly high resolution image. Where let's say we flew a bit higher and this image had a GSD of 5 centimeters per pixel, meaning that each pixel captures 5 centimeters by 5 centimeters of ground. A GSD of 5 centimeters per pixel would be considered a lower resolution image than a 1 centimeter GSD. GSD is influenced by three main factors. So camera resolution, or how many megapixels the camera can capture. Lens field of view, or the amount of ground the camera can capture, really determined by the focal length of the lens. Both of these are fixed parameters based on the sensor you're using. So if you want to change these parameters, you would need to change your sensor. The last is drone altitude, and altitude can be adjusted. The farther you are away from the ground, the larger the field of view will be, therefore the GSD will be larger. So images with a larger GSD have less detail in them. Let's jump over to Pix40 Fields and compare some images to get a better idea of GSD. So here we have some imagery collected by a Mavic 3 multispectral for a green on brown weed detection. If you come over to info, you can see that the GSD here is 0.342, which is really high resolution imagery. So we can zoom in here, and once we start to see our pixels, you can see those. So each pixel here will be 0.3 centimeters by 0.3 centimeters. So you get a lot of pixels on your target here. Whereas if we switch over to the map collected at 120 meters, this GSD is 3.26 centimeters per pixel. So this is that exact same weed, but we don't have as much resolution in the image, so we can't really see it at all. So I'll switch back to the 0.3 centimeter per pixel, and then back to the 3.2 centimeter per pixel. So a lot more resolution in the image with the GSD of 0.34 as opposed to a GSD of 3.26. It's safe to say that GSD is probably the single most important factor when it comes to mapping anything for an agricultural application, whether it be a weed detection, a crop health analysis, or just to generate boundary lines. Let me show you an example. If I'm mapping a paddock for a green on brown weed detection using RGB imagery, I want to have a pretty low GSD. Let's come take a look at a couple of these weeds in this map. So this weed I measured to have a diameter of about 5 centimeters, and we have a pretty good amount of pixels on this target right there. Whereas if we switch over to the map with a GSD of 3.261 centimeters, we can't see that weed at all. So really, for a weed that's 5 centimeters in diameter, I recommend having at least a GSD of 0.4 centimeters per pixel. You also want to be sure that your GSD is sized appropriately to your mapping project, so that way you save flight time and data volume when you're collecting your data. Here's a map of a strawberry farm just outside of Melbourne who has started using drones to spray their crops. If I'm mapping this farm to build my spray drone boundary lines and obstacles in DJI Terra, a 0.4 centimeter per pixel GSD would be overkill and take hours longer to fly and hours longer to process. So this map was collected at 80 meters above the ground with a Mavic 3 multispectral. If I take a look at the quality report here, I can see that the GSD is 2.6 centimeters per pixel. Now I'll come into the agricultural application, and with a GSD at 2.6 centimeters per pixel, I can clearly see all the obstacles and exactly where I want to place my boundaries for the spray drone. Crop health maps also don't need a super low GSD. Let's take a look at an NDVI map from some multispectral imagery in Pix40 Fields. This multispectral orthomosaic has a GSD of 10.2 centimeters per pixel. If I'm looking for general trends here across the paddock, I really don't need to spend the time collecting sub-centimeter GSD data on this paddock. I'll come over here and generate the NDVI. And with a 10 centimeter GSD, you can still see the trends where crop might be not doing so well, and then crop will be doing a little bit better over here, and use this to create your variable rate prescription file. For stand counts in a software program like Agremo, a minimum GSD of 2.5 centimeters per pixel is required. I'd shoot for probably a 1.5 centimeter per pixel GSD just to make sure that your analysis is successful. And here's an instance where you don't really need to get 0.4 centimeter GSD in order to get a successful stand count. Hopefully this video gave you a little bit more insight into GSD and how to collect imagery for different agricultural applications. If you have any questions, just drop them in the comments or check out the website at horizonagtech.com.au, and thanks.